Today we're going to talk about properties of logarithms. Tomorrow we're going to talk about solving logarithms. So before we can solve logarithms, we have to talk about properties of them so that when we get to solving them tomorrow, you know how to solve them. You know what you're allowed to do with logarithms to be able to solve them. Does that make sense? Okay. So, I think I told you the other day that logarithms and exponents are related. It's important enough to tell you again to make sure you have it in your head and have it on your paper. Okay? Logarithms and exponents are related. How are they related? They are what?
Cousins.
They're cousins, exactly.
Wait, actually?
No, I'm just teasing. Yeah. No. What do you think? They are inverses. Okay? They are inverses of each other, not cousins.
Basically, probably.
Maybe like second cousins, third cousins, okay? But they're inverses, and that's a big deal for you to know, okay? The reason it's a big deal for you to know is because you already know all these, don't you? We've worked on these several different times this year. We've used this foldable several different times this year, haven't we? Okay? But here's the deal. When I start to teach you the brand new stuff that I'm going to teach you today that you've never seen before, because this is the first time you've ever been taught about logarithms, I'm going to refer to this foldable. And the reason I can refer to this foldable is because they're inverses, so a lot of the properties are similar. Okay? So the first thing I want to talk about is the product property. Product property. Okay? The product property says that if I have a logarithm, like log base 4 of xy, I can expand this logarithm. Now when I expand it, it means for every term that's inside the logarithm, I'm going to write the word log once for every term that's inside of the logarithm. So how many terms are inside this logarithm? 2. So over here I've got to write log twice. Okay? I've got to write log base 4 of x, and I've got to write log base 4 of y. But there's a sign that goes in between those. And I want you to tell me what you think it is based on the fact that the product of powers property for exponents says if you multiply like bases, what should you do with their exponents? Add them. So if I'm multiplying two terms inside of a logarithm and I expand, what should I do with them? Add them. Do you see how that feels familiar? Okay. So if I have log base 3 of 2xz, what does that look like if I expand it? How many times am I going to write log? 3 times. One for the 2, one for the x, and one for the z, right? And what sign should be in between each one of those logs? Because, why is it pluses?
Because it's product and power.
These are being multiplied, right? This is the product power. These are being multiplied. So when I'm multiplying inside the log, when I expand it, I add them. So log base 3 of 2 plus log base 3 of x plus log base 3 of z. Now, what base is this logarithm? 3. So what base should every single one of these logarithms be? Right. They should all be 3. This is not going to be 3 and 4 and 5 or something like that. Whatever log base this is, that's what this one is, that's what this one is, that's what this one is. Does that make sense? Okay. Now let's talk about the quotient property. Well, in the quotient property, the problem looks like this. Log base 2 of 3 over x. Knowing what you know about the product property, and when things are multiplied inside the log and we expanded them and I add them, what do you think we're going to do if I'm dividing inside the log? Subtract them. And I didn't even have to tell you, did I? You knew it, even though this is brand new to you, you knew it because you know the properties of exponents, right?
Yes.
Okay? So how many times are we going to write log? Twice, one for the 3 and one for the x. So we're going to write log base 2 of 3 minus log base 2 of x. Now, what do you do if you see this? What are you going to do if you see this?
What is that?
It is ln, right? Have we talked about ln before? Oh, then I get to teach you something new today. Besides all the other new stuff I'm teaching you today. Okay? Log base 2, log base 3, log base 4. We talked, on the very first day we talked about logarithms, we talked about if it just said log with no base, what is that base? 10, right? We don't write it though because that's the common log, right? That's the most common, so we just leave it log. Well, there's another log that's very, very familiar, or very, not familiar, very often used, widely used, and that's this one. It's actually log base E. Do you remember like the 3rd or 4th day of school?
No.
When we talked about different types of numbers, we talked about natural numbers and whole numbers and integers and rational numbers and real numbers, things like that. And I said to you there's some numbers that are irrational, like pi and e. And I told you we wouldn't be using e for a long time. It would be well into the 2nd semester before we used e. Today is the day. Today we're going to talk about the number e. Okay? Now I know you've been told your whole life that e is a letter. That's because it's true. Okay? But e, specifically e in math, we hardly ever, ever, ever use e as a variable because e represents a very specific number. Okay? It was discovered, I don't want to say it was created because it was not created. Okay? It was discovered by a man named Euler. I know that looks like it says Euler, right? But it's Euler. Okay?
So it's probably 11. Or something.
It's what?
Is it 11? Does E stand for 11?
It does not stand for 11. It's actually, hold on, I have to turn the page because it needs a lot more room. You don't have to write this down,
6.
okay? Because I'm not going to make you remember this, but I just want you to know it, okay? This is what E represents. Don't panic. Don't panic. This means E is the sum of all of the numbers from 0 to infinity of 1 over n factorial. Now, this doesn't mean n! That's not what it means. It's not an exclamation point. In math, this is a factorial. That means 1 over 1 factorial.
Yeah.
And I'll tell you 1 factorial is 1. Plus 1 over 2 factorial. Plus 1 over 3 factorial. All the way to infinity. Okay? Factorial means, if I say 2 factorial, it means 2 times 1. If I say 3 factorial, it's 3 times 2 times 1. If I say 4 factorial, it's what?
4 times 3 times 2 times
4
1.
times 3 times 2 times 1. So whatever number it is factorial, it's times all the numbers below it. Does that make sense? Okay? So can you see how this number right here could get really big really quick? Which means this fraction is getting really small really quick, right? Okay? So 1 plus 1 over, 1, because this is 1 over 1 factorial, and 1 factorial is just 1, because 1
Is 1.
is 1, right? Plus 1 over 2 factorial, which would be 2. 1 over 3 factorial, 3 times 2 times 1 would be 6. 1 over 4 factorial, 4 times 3 times 2 times 1, so 24, right? When all those add up together, 2.71828, repeating. It never repeat. I say repeating. I didn't mean repeating. I meant ... continuing, right? It never repeats. It never starts over. It never ends. So this is a rational number, okay? But if you write log base E, mathematicians laugh at you. We don't write that. We write natural log. We call that natural log. When the base is E, that's the natural logarithm. When the base is 10, that's the common logarithm, right? This is the natural logarithm. All the same rules that apply to logs apply to natural logs. Okay? So, but I wanted to give you an example. Now we're back to our property, right? I wanted to give you an example of one just so you have seen that all of the same rules still apply. Okay? Everybody okay with that? Okay. So how am I going to write this? Do you think that I'm trying to trick you on this problem? Probably. Yeah. Okay. I'm not trying to trick you, but it looks kind of like a trick, right? So what do you think I'm going to write first? ln of x, right? Then what? What am I doing? I'm dividing, so I'm subtracting, right? So minus, ln of y. Now what? So you want to put minus ln of z? I'm totally fine with that. But why do you think people think this is a trick? Because if you look at it, it looks like it should be x divided by y divided by z. Well, we don't have that, right? We don't have triple fractions. Does it make sense that both y and z would be in the denominator if I wrote it like this? While this is correct, 100% correct, and if you write this on the test, it will be counted right, a lot of people prefer, oh geez Louise, to write it like this. Do you see that these are the same? If I distributed this negative here and here, wouldn't they both be negative? Why do you think people prefer this way, though? What are the y and the z doing in the denominator to each other? Multiplying. So what should they be doing? Adding. Does that make sense to you? They are both correct. They're both correct. Whichever one of these you write on a test will be correct. Okay? Now you can't write it like this without the parentheses, because that's not correct. If you're gonna add these two that are being multiplied on the denominator, you've got to have the parentheses around it. Yes? Any questions about either the product property or the quotient property? Now let's talk about the power property. Power property problems look like this. Log of x squared. We cannot have exponents inside of logarithms. Okay? We cannot have exponents inside of logarithms. So what we do, what do you think? Power of powers. What did we do here? We multiplied. This power becomes a multiplier. It becomes a multiplier. I basically bring it around in the front of the logarithm as a multiplier. Does that make sense? So now can I give you like a really tough one and see if you can handle it?
Yeah,
Okay.
I got it.
Let's see, log of
29.
Let's do 3x squared y to the 4th over z to the 5th.
No, you got that one. You got that
Oh, I got this one. You don't have this one.
one. No, that's not.
What if it just said that? What would you write?
I don't know.
Log of 3?
Confused.
Right? What are we going to do with this 2?
You're going to move it around to the front.
So plus, because those are being multiplied, 2 log of x.
Plus.
Because that right there is not any different than that problem we just did, is it? Okay. Plus what?
2 or 4 log to the y.
4 log of y
Minus.
minus y. Why is it minus?
Because it's
Because it's dividing.
5 log z.
I thought you said you didn't have it.
Nah, I didn't know that was in my bag for.
Okay, you got it in your bag now.
Yeah, in my bag. Now I just gotta write it.
That's fine. I'll let you write it.
That made me feel a little bit smart, probably.
So on your homework tonight, it's going to ask you to expand or rewrite as a single logarithm. If you're expanding, it's exactly like all the problems I just showed you. You're starting here and you're expanding it to this. You're starting here and expanding it to this. If it says rewrite, I'm not going to give you a whole bunch of new examples for rewrite into a single logarithm, because it's going to say, it's going to give you this and ask for this. It just goes backwards. Okay? Like a short way to say this is, if this is expanding, from here to here is called condensing, isn't it? Okay? What I think the instructions on your homework say, though, is rewrite as a single logarithm. So it gives you this and it wants this. It gives you this and it wants this. Does that make sense? Now, if I knew a couple of shortcuts, would you want to know them?
Probably.
Okay? Then let me tell you a couple of shortcuts. If it says log base 6 of 6, I need you to know what that means. Because that is a shortcut. It's a special property. Okay? In our exponent rules, on our other super amazing stuff page, we have this written. Anything to the 0 is 1. Right? Isn't that a shortcut right there? Yes? This is a shortcut. Let me write the second shortcut I'm going to show you, because these are actually the same shortcut. This says log base 6 of 6. This says log base 6 of 6 squared. What I'm going to tell you first is the answer to this second one is 2. Just 2.
And the first one is just 1.
It is. How do you know
Because
that?
It equals what the exponent.
It equals what the exponent is. And there's not an exponent written here, but you know it's a 1, right? Anytime the base and the base are the same, the answer is just the exponent. So in this case 1, and in this case 2. Okay? Now I will tell you that the homework does try to trick you. Okay? And the homework will give you a problem that looks like this. 2 log base 3 of 3. And the directions are rewrite it or simplify. We saw both directions. That's supposed to say rewrite. Please don't judge me.
So it's just
It's a mess.
2 log.
Rewrite. Okay, so if we're rewriting this, where does this go?
It goes to the exponent.
It goes as an exponent,
So
right?
it's just log 3.
Log base 3 of, what is 3 squared?
Oh, 9.
9. That is what it
Well,
wants
that
as the
is a little
answer.
tricky,
You see what
though.
I'm saying? That's why I'm trying to help you with it, right? You okay with that? Any questions on that?
2.
Any more questions? You okay with product property, quotient property, and power property? You okay with these real quick shortcuts over here? But also don't let them trick you when it asks for this, to rewrite or simplify. Everybody okay?